Lesson 3 is working with functions, and in 3.1 we're going to evaluate functions using different tools. So example 1, we're going to evaluate a function using a table. It says complete the input-output table for f of x equals 1/2 x plus 4. And we filled in tables before, and it actually works the same way. The only little change that you'll see is we're going to be using function notation. So on our table, all the x values are on the left side, and these are going to be all of our input values, meaning those are the numbers that we put into the function. And then on the right side of our table, you can see it's labeled with f of x, but remember f of x and y are like the same exact thing. It's just a little bit different way of writing it. So f of x and y are interchangeable, and then the kind of name of that group is called the output values. So we're going to put the input values in all the x's and then simplify, and the things that we get out are what is going to go on the right side of the table. So our first input value, that's x equals -2. So we're going to take -2 and put it in the function where x is, and we're going to write it in for both of them. So then this, remember, is read as like f of x. So when I put the -2 in, we're going to read it as f of -2. So the -2 replaces that x, and it's also going to replace this x. So it'd be f of -2 equals 1/2, and then times -2 here as well. So that -2 goes in anywhere you see an x, and then we bring down the +4. Everything else in the equation stays the same, just the x's get swapped out for -2's, and then we simplify. Okay, so I'm just going to draw the equal sign, and we'll simplify like the right side of it for now. So remember, when we simplify, we use order of operations, so we'd have to multiply before adding. So I would multiply 1/2 times -2. So half of -2 would be -1, and then +4. And then now that we've multiplied, we can go ahead and add these two together. So it'd be -1 plus 4 is +3. So f of -2 is +3. So that +3 goes next to the -2 on the right side of the table. And then we just get to kind of repeat that process, but with each different x value. So the next x value will be -1. So we'll find f of -1 equals, it'll be 1/2. And then instead of times x, you'll put a -1 in there plus 4. So -1 went in for both x's, and then now we simplify. And the good news is when you're working with a table, working with the same function each time, the order that you're simplifying in things in does not change. So we would still multiply first. So it'd be 1/2 times -1, which is -1/2, and then plus 4. And then now that we've multiplied, we can go ahead and add these two together. So -1/2 plus 4, that's the same thing as 4 minus 1/2. So it'd be 3.5. So it'd be equal to 3.5. And you can, if you want to, you can do a mixed number, or this is a mixed number. You could do an improper fraction or a decimal if you prefer. But it'd be f of -1 equals 3.5. So next to -1 on the table, we'll put a 3.5. And then the next x value we'll put in is x equals 0. So we'll find f of 0. And then that's going to be 1/2 times 0 for x, and then plus 4. We'll simplify the multiplication first, so we'll do 1/2 times 0. So anything times 0 is 0, so 1/2 times 0 would still be 0. And then plus 4. And then now we can add 0 plus 4 to get our output value. So 0 plus 4 is 4, so it'd be f of 0 equals 4. So 4 fills in the next spot on our table. And then our next x value is 1. So we'll do f of 1 equals 1/2 times 1 plus 4. So x equals 1 and 1 for both the x's. 1/2 times 1, anything times 1 is itself, it stays the same, so that would be 1/2. If we simplify the multiplication, and then plus 4, And then since I wrote the 3.5 as a mixed number, I'm just going to write this as a mixed number as well. So 1/2 plus 4 would be 4.5. So f of 1 equals 4.5. That fills in the next spot on the table. And then the last x value that we put in is x equals 2. So it'd be f of 2 equals 1/2 times 2 goes in for x, and then plus 4. And then we simplify the multiplication first. So 1/2 times 2, half of 2 is 1, and then plus 4. And then now we can add the 1 and the 4 together to get 5. So f of 2 is 5, and that fills in the last spot on our table. So when you're asked to fill in a table with a given function, the way that you do it is you take each of the x values from the table and you put them into the function or the equation in separate little sections. But you have to do one for each individual x value, and that's how you get the f of x or the y value that goes next to it. And then just a review of like kind of how we read function notation one more time. This part right here is read as f of x, and then when we actually put in a number for it, we like read it as like f of -2. So it's always the letter f and then of, and then whatever's inside of the parentheses. So that'd be f of -2, this is f of -1, and so on. And then the output that we get after we actually simplify the equation is what goes on the other side of the table. Okay, so example 2, evaluating a function using a graph. So you could see that the function itself is labeled as h of x, and then the problem says to find h of 8. So I'm gonna just rewrite that h of x right above it. And you can see that like in the spot of where the x normally was, there's an 8 there now. So the 8 is replacing the x. So another way of asking this same question or this problem is saying, where does x equal 8? So where does x equal 8? Well, if we look on the x-axis, 8 is right here. But we want to know like where on the function, which is that blue line. So where on the function does x equal 8? Well, it's right here, above the like 8 on the x-axis. So then that point is 8, 3, because we are going like right 8 and then we go up 3 on the y-axis. So h of 8 is going to be the output or the y-coordinate from that point. Remember that like points are written as the input first. So our input is 8 and then the output second. So our output is 3. So h of 8 is going to be equal to 3, and then just leave yourself a note, a reminder, like this is the input right here, and then this is the output right here, and that the input is typically our x value and the output is typically our y value. So the tricky thing about functions is like there's a lot of different ways of writing like something that kind of means the same thing. So it's important to get comfortable with the fact that like input is x value, output is y value. And then if I have to evaluate a function using a graph, I go to that x value that I'm given on the graph, and my answer is going to be the y value, the second number from that point. So h of 8 equals 3. Okay, so example 3. 3a is what is the value of f of 3 for the function f of x equals 3x squared minus 2x plus 5. So we did something really similar to this with the first example with the table. We just don't have to do an entire table this time. We just get to put in like our 1x value is all. So it says, what is the value of f of 3 for the function f of x? So in f of x, the input is just x, but this says what is f of 3. So that means that we take the 3 and we put it in for all of the x's. All of them. So it'd be f of 3. So we got the first one. And then that equals, the rest of the function kind of becomes like a template. So like this will still be there. The squared will still be there. This is there. This is, oh, yeah, that's still there. It's just really the only thing is we're taking out the x's and we're putting 3's in. So it'd be 3. And then instead of x squared, it would be 3 squared from the 3 that we put in for the x. and then minus 2 times the 3 that we're putting in for all the x's, and then plus 5, and then the 5 doesn't change at all because there's no x around it. So really, like, these parts are kind of like a shell or like a template of the function, and then the only thing that's changing is the x's, and they're getting like replaced with 3's. Okay, and then now we need to simplify, so I'm going to erase some of the like kind of clutter. So when we simplify, remember order of operations, which is like PEMDAS or GEMS, but we would simplify parentheses first, but that's really referring to if you can simplify inside of the parentheses, which like this is just a 3 and so is this, there's nothing to do there. So next would be exponents. So we're going to simplify exponents first. So we're going to do 3 squared. So then this would be 3, and then 3 squared means like 3 times 3, like 2 3's being multiplied together. So 3 times 3 is 9 from 3 squared, and then minus 2 times 3 plus 5. So we did exponents, and then now we're going to do multiplication. So we can multiply 3 times 9. So 3 times 9 is 27. We can also separately multiply the negative 2 times 3, and that would be a negative 6 plus 5. And then now we have like addition and subtraction right here. But even though the A comes before the S, the order doesn't matter. You just go left to right when it comes to addition or subtraction. So we would do like 27 minus 6, which is 21. And then I can bring down my like plus 5 after that, or you could do it all in one step if you want to. But 21 plus 5 would end up being 26. So f of 3 equals 26. And then for B, this is a very similar problem, so this would be a good one to like pause and test yourself on. But B says, what is the value of g of negative 2 for the function g of x equals 6x plus 10? So this one you can see the function is named g, but it's like the same concept as the previous example. So what is the value of g of negative 2? So our input is x, but we're actually finding g of negative 2, so that means we put negative 2 in for both of the x's. So it'd be g of negative 2, and then equals 6 times negative 2, and then plus 10, and that plus 10 doesn't change at all because it doesn't have an x attached to it. So kind of similar to before, like the parts of the function that don't have an x are kind of like a template, and then the only thing that changes is the x gets switched out for whatever x we're given in the problem, which in this case is negative 2. Okay, and then we'll simplify, we'll follow order of operations to do that. So this problem just has multiplication and addition. So we would multiply first before adding. So 6 times negative 2 would be negative 12. And then we bring down the plus 10. And then now we can add these two together. So it'd be g of negative 2 equals negative 12 plus 10 is negative 2. Because you have one positive, one negative, so you could subtract them to get 2, and then the bigger number was negative, so our outcome is negative. So g of negative 2 equals negative 2. Okay, and then moving down to 3.2 is finding function rules with a table. So I kind of put some steps up there because this is one of those things where it's kind of nice to have the written steps, but they're kind of short, so I apologize. But example 1, it says what rule defines f of x, and we're given f of x in a table. And in 3.2, all of the rules are linear, and so we're going to write all of our rules in the form y equals mx plus b. Okay, so you may have noticed like something kind of like new as far as like a symbol in the written steps, but 1 says find m equals, and then there's like these crazy triangles. So these triangles mean change. They're like a symbol that's called delta, and it stands for change. So the change in y, and then this would be the change in x is what it means. And it's actually the same thing as slope, like rise over run. It's just written a little bit differently. And it kind of clicks a little bit more with the table sometimes. So find m equals the change in y over the change in x from the table and put it in y equals mx plus b, where m is. So this is m. And then number 2, or step 2, says find x equals 0 on the table. That's referring to like this spot. To find b, and then we'll put that into y equals mx plus b for b. And that doesn't have to mean a whole lot yet because that's very new to us. Okay, so our table, you can see it's like the points 0, -4, 1, -2, 2, 0, and so on. So I want to kind of like go from each of our different y values and look how they're changing. So what I mean by that is, and hold on, just remember, sorry, f of x and y are interchangeable. So when I'm saying the y values, I mean like the f of x side. So the change is we're going from -4 to -2. So to get from -4 to -2, we would have to go up 2. And then -2 to 0. So to go from -2 to 0, we'd have to go up 2. And from 0 to 2, we'd have to go up 2. 2 to 4, up 2, 4 to 6, up 2 also. So that's our change in y. And then for all of our x's, we're going from 0 to 1, so the change would be up 1. We're going from 1 to 2, so the change would be plus 1 also. 2 to 3, the change is plus 1. 3 to 4, the change is plus 1, and 4 to 5, the change is also plus 1. So when I say find m equals the change in y over the change in x, I really just need a pair. So like how between, this is 1 point, and this is a second point, and between those 2 points, the change in y is 2, and the change in x is 1. So the change in y is 2, and the change in x is 1. So that means that m equals 2. So I'm going to take that 2 and I'm going to put it in y equals mx plus b. So that's my first step. That's step number 1. So it'll be y equals 2x plus b, since the m that we found was 2. So that's step 1. We're done with that one. And then step 2 says find x equals 0 on the table to find b, then put it in y equals mx plus b for b, which is right here. Okay, so now if I want to find x equals 0 on the table, you can see it's right here. I need that full point. And the reason I need that full point is because this is going to be b. It ends up being our y-intercept, which is what b is. Because if we think about what that point would be on a graph, you don't have to sketch this, but if you think about what that point would be on a graph, 0, -4, since the x-coordinate is 0, you wouldn't go up or down at all. You would just go down 4, which is right here, which is a y-intercept. So anytime you find x equals 0 on the table, the other number is going to be b. So b equals 4. And then now we just need to take that 4 and put it in here, and then that's going to give us our final answer. So y equals 2x plus 2. So we found m equals 2 and b equals 2, and we plugged them in. So that's why the steps are kind of short, because it's like not a super long problem, but you can imagine like if you didn't know what to do, it would be hard to like figure out where to start. So y equals 2x plus 2. And we'll move on to example 2, which is another similar one to this. So if you wanted to practice example 2 on your own, that would be a good one to pause the video on. So example 2, write a rule that defines g of x. Same thing, we're going to write it in the form y equals mx plus b. I'm actually going to backtrack a little bit just because I have one little correction that's going to drive me crazy if I don't. So we talked about how like y and f of x are like interchangeable here. They mean the same thing. And since the instructions told us to write a rule that defines f of x, we really do want to use f of x instead of y is the only thing in our final answer. So they mean the same thing, yes, but just to like perfectly match the directions, we should write our final answer as f of x equals 2x plus 2. Okay, so example 2, write a rule that finds g of x. So same set of steps, we're going to find m equals the change in y over the change in x, and we're going to put that into y equals mx plus b. So we'll find the change on just a few values this time. So on the g of x side, we're going from 4 to 8, so we're going up 4, and then we go from 8 to 12, so we're going up 4 as well, and 12 to 16 up 4 again. And then on the x side, we're going from 3 to 4, so plus 1, 4 to 5, so we're going up 1 there as well, and then 5 to 6, so we're going up there, up 1 as well there. So remember that g of x or f of x or whatever of x is the same thing as y. The right side of the table is pretty much always y. So the change in y is we're going up 4, while the change in x is we're going up 1. So m equals the change in y over the change in x. The change in y was that we were going up 4. The change in x is that we were going up 1. So it'd be 4 over 1 or just 4 for the slope. So we're going to go ahead and put that in for m. So it'd be y equals 4x and then plus b. And then to find b, we're going to go on to, oh, I didn't realize that this it was one of those auto numbering things. So it should be step 1 and step 2 instead of 3 and 4. I didn't recognize that. But for step 2, to find b, it says find x equals 0 on the table to find b, and then put it into y equals mx plus b. So if we look on our table, there is no x equals 0. The smallest one is 3, but we can count backwards on our table to get there. So what I'm going to do is I'm going to kind of extend our table up a little bit. And then the smallest number on our x value is 3, so it'd go down to 2, and then 1 and 0. And then we see that when we go down on the table, we add 4 each time. So if I want to go up on my table and go backwards, I need to subtract 4. So if I was going backwards, I would do minus 4, so that would be a 0. And then I would have to go up again to I would subtract 4 again to go up to negative 4. And then I would have to go up one more time to get to where x is supposed to be 0. So negative 4, and if I go down 4 more, it would be negative 8. So you can count up or down your table as much as you need to, but to get b, you have to find the point that specifically has x equals 0 next to it. So that would be this point. And then the other number from it, the y or the g of x, that's going to be b. So b is negative 8, and then we can take that and we can put it in here. And then same thing, the instructions tell us to define g of x. So instead of writing y equals, we would put g of x as our final answer. So g of x equals 4x and then minus 20. I don't know where that number came from, but minus 8, excuse me, from this point up here. Okay, so g of x equals 4x minus 8. So biggest thing, you find the slope. That's the change in y over the change in x, and you can count the change on the table. How on this side it was we were adding 4 each time. This one we were adding 1 each time, so it's 4 over 1. And then to find b, you have to find the point that has x equals 0. If it's not on your table, you could count backwards on your table to get there. 3.3 is real-world examples of functions. So starting up at the top, whenever you hear a phrase like 55 miles per hour or $25 each, you can create a linear model to represent the situation. Linear models can represent lots of real-life situations, such as distance traveled based on time or the amount of a paycheck based on the number of hours worked. So linear functions can represent something that has a constant rate of change, meaning if you are consistently driving at 55 miles per hour, or if you're buying an item or multiple items for $25 each. You wouldn't really be able to use a linear model if your driving speed was changing over time, or if the price of your item was changing over time. They would have to be constant. So moving down to example 1. A cell phone company charges a standard monthly fee of $50 for service and an additional $10 for each gigabyte of data used for internet services. Write an equation that models the situation and use it to find out the monthly bill if 6 gigabytes of data are used. So if we want to figure out like how much you're going to get charged during a month, so you know that you're going to get hit with that $50 service fee. So it's a standard monthly fee of $50 no matter what, no matter how much data you use, you're going to get charged $50. So let's say 50. That's for sure there. So that's part of it. And then the next part, it says, and an additional $10 for each gigabyte of data used. So you get charged an additional 10. So I'm going to add 10. But it's not just 10, it's $10 for each gigabyte used. So like if you use 1 gig, you would do 10 times 1. If you use 2 gigs, you get charged like 10 times 2, $20. 3 gigs would be 10 times 3. So if you're getting charged $10 for each gigabyte, you have to take 10 and multiply it by the amount of gigabytes that you go through. So to represent that, we can use X or G, whatever you want. But that's going to be a variable because that depends on how much you use. So G is going to be the number of gigabytes used. So to get our total monthly bill, it's the $50 flat fee and then plus $10 times each gig that we used, but that's it. That's all of it together. So that's enough. We just have to like kind of finish out our rule in our function notation. So we can use any variables that we want. The one we did already pick G as our like kind of input variable, so we'll have to involve G. But let's say like we want our function to be like C for cell phone bill. So I would write that as C of G. So this is like here. The C is for our cell phone bill. And the G is based on like how many gigs we use. So that's like saying C of G is like the total bill based on number of gigs used. So C of G equals 50 plus 10G. You could switch the order as well. If you put the 50 like after the 10G, that would be fine. But this is perfectly fine to like leave our final answer in. I will say a lot of the time you'll see like the variable part first. So I think I'm just going to reorder it that way just so it looks, at least just we're getting more comfortable with reordering it if we ever needed to. So instead of 50 first, I'm going to put the 10G and then plus 50 after. So C of G equals 10G plus 50. So our problem, like the word problem itself, it says write an equation or a function that models the situation. That's this answer. So we've done that. And then the second part says, and use it to find out the monthly bill if 6 gigabytes of data are used. So 6 gigabytes, that means that G gigabytes is going to be 6. So I got to take that and put it in there. So we'll find C of 6. And that equals, so we're going to put 6 in for G in both spots. So equals 10 times 6, and then plus 50. And then we'll simplify, and that'll tell us our total bill if we were to use 6 gigabytes. So we would multiply before adding, so we'll do 10 times 6, which is 60, and then plus 50, and then now I can do 60 plus 50, which is 110, and since this is a monthly bill, I'm going to add a $sign. So C of 6, our cell phone bill, if we used 6 gigabytes, would be $110.